Hello and welcome to Lecture 3. Today we are going to get into SketchUp and look at forms of measurement. What is our objective for the day? We're going to come away with an understanding of the golden ratio, the Fibonacci sequence, and Le Corbusier's modular man. And then we are going to model furniture looking at inspiration from Le Corbusier's modular man. We're going to model that in SketchUp. So let's get into SketchUp first. I'm working in SketchUp Pro 2021. Yours might look slightly different if you're using a different version. I'm going to open up the architectural template. And right below that it says inches, so let's open that up. SketchUp opens in its typical view. And for this lesson, we're going to need at least 2 toolbars. I like to use the Views toolbar as well as the large toolbar set. In order to get these toolbars, if you don't have them on your screen, you're going to simply right-click, bring your cursor up to the top of the page, right-click, and select the tools that you need to use. I like the Views tab because it allows me to look in plan very quickly or in any elevation. So I'm going to start with a square. You can touch the rectangle button or simply use R for the rectangle tool. So we're just going to draw a simple square. You'll notice that SketchUp gives you a diagonal that represents the perfect square. So what we're going to do is we're going to create the golden ratio in SketchUp before I describe to you exactly why it is so important. We need to draw and find the center line of a square, and we do that by locating its 2 diagonals, connecting the corners of the square. You can use your pencil, line tool, button, or simply press L as a keyboard shortcut command and draw the diagonals across the square. We're then going to use the Pi tool. The button is to the left here. And we're going to locate the center point of the square. Again, this is called a snap point, when we can snap to a midpoint or a tangent. We're going to snap the Pi tool to the center bottom of the square. Move our cursor up to the upper right-hand corner of that square, click again, and drag the arc down to that ground line, the x-axis. To get out of commands, you simply hit the space bar twice. I'm then going to use the line tool. I touched L or pencil and drew a line to connect and create a rectilinear shape. Now what we've done here is we've created a golden ratio. The slides to the right will explain that in language as well. But just like when we hit R for a square and SketchUp created the perfect square, SketchUp also understands proportions of the golden ratio. In order to align this, I'm going to draw a line upward, hit R for rectangle, and then I'm going to draw a rectilinear shape until it almost mimics, you can see slightly the dashed green line on the y-axis, mimics this rectangle I just drew. So SketchUp recognizes that this is a proportion that we may want to draw with and gives us that dashed line as a guide. All right, in order to erase that line, I can use E which gives me the eraser tool, and select that line. So that now I have two rectangles that are in the golden ratio. And you might be wondering, why is this so significant? Why are we even trying to understand natural orders or formal ordering systems as an architecture student? So let's go back to ancient times, that is before the internet. When man was trying to understand the way the world was shaped and what nature could give us as inspiration, or try to understand maybe even the own measurement of our bodies, so man determined that there was this proportion, right? What is this golden ratio, the ratio of proportion? If we take a look at all of the images here on the screen, right? I show a hand in a spiral, and then I show a nautilus shell. Is there a relationship that we can determine that is similar between all of these things? Yes. So let's say that the relationship from the top of our finger to the first knuckle is the same relationship of, or compare that measurement to the top of the finger to the base of the finger. All right, that is a proportion. Let's say 1 to 1.5. You can take out your measuring tape or even just simply do it with your own hands, right? Can you see a 1 to a 1.5 relationship there? Then in ancient times, we started taking a look at the way trees were formed. The way, as an example, as I show here on the screen, the nautilus shell. And we'll look at how the proportions of the hand relate to the nautilus shell here in a minute. But when it was determined that all of these proportions were similar, what man thought was that he had kind of discovered the language of the gods. Myron Barnstone, I show a link on the bottom, gives a really great lecture about the way in which man decided to use this relationship as we started to build temples and piazzas, Italian Renaissance. They used these proportions because they thought it reflected what God wanted, a form of honor to a higher system. Or if we built in this way, we were honoring a higher system, a higher being, right? And it was our way of agreeing with this whole world and nature. And so then if we take a look, these are examples from Kimberly Alam's publications, The Geometry of Design. And what she does is she looks at a couple pieces of art to understand how this golden ratio finds its way, not even only in architecture, temples and piazzas, but also in art. So here we're breaking down a painting where the formal action occurs at the intersection of this square to rectangle relationship that we're going to draw next in SketchUp. So notice where the action is happening, right? Right at that intersection of these proportions. So I said in the beginning, we're taking a look at the golden ratio, the Fibonacci sequence, and the modular man. So now we're on to the Fibonacci sequence. And here we start to understand the way math and a combination or dimension of measurements are used in succession to define and mathematically dimension that spiral that we form with the golden ratio. All right, so what's the Fibonacci sequence? What it is that there is a sequence into infinity. If we take a look at two numbers, so we're going to start with 1 and duplicate it just to begin. All right, so 1 plus 1 is 2, right, as we see in the image. And then if you look into the next image, up to the upper right, what we start to do is we add the two previous numbers. So if 1 and 1 is 2, and then we move on, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. That relationship can be shown in the spiral by the dimension of units, okay? So if 1 plus 2 equals 3, the dimension from the bottom of this square to the top of 3 units is then compared to 2 plus 3 equals 5, right? The next square would be a dimension of 5, 5 plus 3, 8, dimension of 8 units. And then we create a spiral that mimics this proportion of nature. To look at the units of the human body, again, one more time, you can curl your finger. We get that 1 to almost 1.5 relationship. 1 to 1.618 is what it is mathematically exactly. As I was verbalizing initially with the dimensions of the knuckle to the finger to the hand to the elbow, you can see that here diagrammed out. So why do we need to know all of this to be an architect? Okay, so once you have an understanding of your environment, right, nature, we're creating things, we're designing things to allow people to have a better life, right, or shelter or food, right? We're fixing a problem with design solutions. So once you understand yourself and the way you move and the way you bend, you start to understand how to create a preferred environment for people. So let's draft in SketchUp again. So let's begin with the second rectangle we created. We're going to start by drawing a diagonal across the entire rectangle. I'm going to use the L for line tool and my snaps to an endpoint. The next line I'm going to draw is a perpendicular line, right? A 90-degree line that goes from the bottom right endpoint through that diagonal. And if it turns pink, right, that is a reference to the fact that we are perpendicular. And then from where that line intersects the top of the rectangle, I'm going to draw a line down. Do you see the relationship then between these two rectangles? Yes. All right, I'm going to use the eraser tool because what I'm trying to draw is this perfect spiral. I'm going to erase, I'm going to erase the top line. I'm then going to draw another line using L or the line button where that rectilinear shape we last drew intersects the bottom. I'm going to draw a line through this diagonal, again making sure it is pink, perfectly perpendicular. Where that touches the right side of the rectangle, I'm going to draw a line from here back. Again, now I see a smaller square to rectangle. Anytime, this is a side note, I'll draw a rectangle off to the side. Anytime a rectangle shares a diagonal, the proportions of that rectangle are the same. So although they're at different scales, right, that's a smaller scale rectangle than this large rectangle, the proportion of each side of that rectangle is the same no matter the scale. All right, deleting that. Let's continue on. I'm going to leave the diagonal across the rectangle and erase using E. I'll zoom in. Then I'll draw L line. I'm trying to draw through a perpendicular line through the original diagonal. Draw a vertical up. Again, I have a smaller square and rectangle. I'm going to do this 2 or 3 more times. Leaving the main diagonal, and why don't we just clean up everything else outside of that rectangle? Make this less confusing. L for line, upper right midpoint, make sure the line is pink, goes across. Whoops. And I draw a smaller rectangle. E, erase all except for, and it's hard to determine scale, right? As we zoom in and out of here. I'm going to use L again. Make sure it turns pink so that it is, sometimes I accidentally click, but the second line that we draw will remain the pink perpendicular. Erase all but the main. And then L again for line, crossing through pink. Okay, and we continue to get smaller and smaller rectangles. Okay, good enough. Now I want to start drawing the nautilus shell shape, the curve. And I'm going to use a 2-point arc to do that. So that's here on the left, this button. Let's touch that. And I'm simply going to use the snapping points end to end. And then I click one more time to let that arc land. Next square, I'm going to click on the diagonals and then touch on the face. And I'm going to continue doing that for each square. Sometimes you accidentally draw things the wrong way. That square should have been on top, but let's leave the arc there. Now let's say we want to use these perfect proportions in order to design something, right? I think I mentioned earlier we're going to design some furniture today. But let's look at tools of measurement in SketchUp first. I have in that large toolbar a dimension string. If I click the dimension string, left click, and then touch endpoints and drag it up, touch again, I start to see the dimensions or the side dimensions of the proportions of that rectangle. We can also use the measuring tape tool. Click twice. And notice the bottom left of my screen where it says length, 7 feet 9 5/8 inches. The other thing I can do is to draw a line at a specific length. So again, I'll use L for line tool. Click once, drag on the axis, and I'm going to type in 12 apostrophe for feet, enter. Great. I can also do inches. Type in L again. I can say 12, and then when you're putting something in quotes, we're going to use that button for inches. Enter. And let's just dimension these to make sure that they are the desired length. Perfect. So I mentioned earlier that we were going to build furniture off of a specific set of proportions. So that measuring tool is going to be really helpful when we need to have measurements that correspond to people. That's what we're designing for, right? But let's see how we can use proportions that we've already drawn to create a few things. I've zoomed out. If at any time you accidentally rotate around and lose your view, again, use that Views tab. Looks like a house in many different views. Hover over top so we can look at things in plan. I'm going to click left, drag right, click left, drag right, grab the entire shell shape. I'm going to hit Control C to copy, Control V to paste, and click it again. Everything is still highlighted. The other way of grabbing everything in a view is to double click on it, or I'm sorry, triple click on it, and it grabs everything. Let's say I want to rotate this up or down or mirror it. We'll do both of those actions, right? Because sometimes it's easier to draw things in the Z direction, Z dimension. Rotation in SketchUp is a little tricky. We're going to use the protractor tool or the rotate tool. This one has an odd keyboard shortcut command, as in that it's Q and not R. So we can hit Q or this rotation command. And notice how it's giving me a blue rotation, or blue protractor rather. I can use the directional arrows on my keyboard. So if I touch the up arrow, look at your arrow keyboard shortcut or your arrows on your keyboard and push the right arrow. Push the left arrow. Notice how this changes the direction of rotation. So let's end on the right arrow. I'll zoom around here. Click to an endpoint. Click once. Drag your mouse along the edge that you're going to rotate. Click a second time and rotate up. And notice that this stops in certain key rotations, right? So it kind of clicks if you don't double click the left mouse in certain directions. And when you're in the correct one you want, you can either type 90 or click again with the left mouse. All right. So now this is in a vertical elevation plane. Again, if I get lost, I can use my elevation plane or my plan in the views. Let's hit Control V again. Another golden ratio. Place that down. Let's say I want to mirror this. I can triple click the object, right click, and we're going to use flip along. What happens when I flip along red? It's using the red axis to flip. What happens if I flip along green? It flips it along the green axis, right, or the Y. So I can use this to create a few things. Let's do that push-pull tool. You can hit P, right? So I can start to push and pull the golden section and imagine that maybe this could be a really funky bench in a park, right? Okay, how else can I manipulate this using a new tool? Let's hit L for line again. Draw a line across the top and select that line and hit M. I'm moving that line. I can also use the Move tool. Just like we use the arrows to pinpoint the direction of rotation, I can use those arrows to be very specific about how I want this line to move. So I'm going to touch the line again, and it wants to move in a lot of different directions, right? But if I click the up arrow, it will only move in that vertical Z direction. Why is this important? Well, if I want to ever create a gable roof, let's do this together. Hit R for rectangle, L to draw a ridge line, select the line, hit M. Want to move it in vertical, so I hit the up arrow, and I have a very simple gable roof. Let's move on to the last item to learn today. And we're going to be introduced to Le Corbusier. He was born in Switzerland, considered a Swiss-French architect because he moved and became a French citizen in the 1930s. And we're going to take a look at what is called his modular man. So let's think back. We've learned about the golden ratio, the Fibonacci sequence, right? And we start to see in the silhouette of Le Corbusier's man a series of these proportions that he developed, right? As an architect, he was trying to figure out what is a comfortable step height, what's a comfortable bench height, or a stand-up countertop height, or what should a door frame be measured as, right? So what we're going to use today in order to create some furniture of our own is an image of the Le Corbusier silhouette, modular man, in order to develop a series of furniture that respects proportions and accurate dimensions of things that we use. So before you start to sketch out your ideas for furniture, get your measuring tape out, and I want you to measure a few things. Measure the seat height of your chair to the floor. Measure the tabletop height to the floor. Measure a dimension of the floor to the top or the opening of a door jamb. And then if you have anywhere in your home or office that is a stand-up countertop height, I want you to take a measurement of that. So note those 4 measurements for yourself. Then we are going to Google an image of the modular man. I'd like you to select this image. I'm going to right-click, save the image as Le Corbusier modular man, and that's going on my desktop. I can minimize. If I want to take and pull an image into SketchUp, I'm going to go to File, Import. Find that image on my desktop and click Import. Then I see this image that comes in at any scale. You can put it at a rather large scale to start. I've just clicked once, clicked again to scale it, and then let's go to Plan View. So let's look at the top. I am going to give you a few measurements. You can also look up the PDF at Fairmont State's Blackboard. This PDF of the lecture will be in that section of course content for you. I want a bench height to be at 19 inches. So I need to scale my image to be 19 inches. I'm going to do that in Plan. I'm going to use the L tool, click on the image, drag it up. Mine is large at 3 feet. I'm going to hit 19 inches, enter. Okay, so there's the line of where the bench should be. But in the image, it's much larger. It's very important that when we try to scale an image down to the dimension we'd like it, because the image isn't a smart component, it isn't anything we drew in SketchUp, that we select both the line that is the incorrect dimension and the image. Now I'm going to use the tape measuring tool, that's over here, and I'm going to use that line to tell the image how large I want it to be. So I click the bottom point of the line I drew, the top point, and then you'll notice at the bottom of our screen that I should enter the distance to resize the model. I'm going to use my keyboard 19, quotation mark for inches, and enter. SketchUp will ask, do I want to resize that model? I say yes. Then I will dimension this again to make sure that the image was resized. I can use my dimension line tool. And sure enough, it is the accurate size now. Okay, I want you to step away from the computer, and I want you again to draw those 4 items. So you're going to draw a bench, draw a table, a stand-up counter, and a door frame. You need to come to class, the next class, with all 4 of these items in a SketchUp file that is available to you in class. Again, you may use OneDrive or some other cloud-based application so that you can open up your files on multiple computers. We're going to use this for our next project. After you sketch those, so you've paused this and now you're back, we're going to use this modular image in order to help you draw those items to scale. I'm going to hit the space bar to get out of my command, grab both my 19-inch line and the image, and I want to rotate this into the vertical dimension so I can use it as an elevation. Again, I'm going to use Q or the button for rotate. I'm going to hit the right arrow, click an endpoint once, drag it along the image, click again, and then I can type 90, enter, and it will bring it up to a perfect 90. From this point, I can draw on the image and extrude by push-pull, that's the P, to create benches, a stand-up counter height, and try to mimic the design that you've created in your sketchbook as accurately as possible. I look forward to seeing your bench, table, stand-up counter, and door frames in the next class. Thank you.